This is 12.6, specifically number 28. So that you've gone through a word problem with me, because there are 2 of those on the test, and I want to make sure you're ready for them. So you ride your bike to a beach that's 15 miles away. So the beach is 15 miles away. Your average speed on the way home is 5 miles per hour less than your average speed on the way to the beach. So here's your house, and here's the beach. And here's your bike. Actually, it's a good thing I didn't enter any drawing contests. So you're riding your bike to the beach, and it's 15 miles away. And your average speed is 5 miles per hour less. So your average speed on the way there is R at rate R. But on the way home, you're doing the same mileage, 15 miles, but your rate is going to be 5 miles per hour less. So R minus 5. Probably you're tired from a long day at the beach. Write an equation that gives the total travel time as a function of your average speed in miles per hour. So you want T, your total travel time, which is going to be trip to beach, right? Travel time to beach plus trip from beach, right? In both directions. Now the governing equation is distance equals rate times time. But the thing is, you don't want distance and you want rate, you just want time. Well, if you solve for T, you have to divide both sides by R. So T equals distance over rate. And your rate is going to end up in the denominator. Well, T is going to be the distance to the beach divided by your rate to the beach, right? So I'm still using words. R to beach plus the distance from the beach over the rate from the beach, right? Well, what do you know? And I'm going to switch pens because this poor pen is dying. Let's see. So, what did the problem tell me? It told me the distance to the beach is 15 miles. And my rate to the beach, they didn't tell me, so that's just my rate R. But on the way home, I have, again, it's 15 minutes, but my rate is R minus 5. I'm going 5 miles an hour slower. So I have an equation, but the thing is, I need a common denominator. And so I have to, my common denominator, my LCD, is going to be R times R minus 5. That means I have to multiply the top by R minus 5 and the bottom by R minus 5. And here, I'm going to multiply the top by R and the bottom by R minus 5. Now I can combine my numerators, and I get 15 times R minus 5 plus 15R over R times R minus 5. I'm going to multiply this out and get 30r minus, let's see, 15r times 5, that's 50 plus 75. So 15r minus 75 plus 15r, I'm going to end up with 30r minus 75 over r times r minus 5. And that is my equation. So I've answered the first portion of this. The second part says find a total travel time if you bike to the beach at an average speed of 15 miles an hour. In other words, they're giving you what r is. So what is t? So what is t if r equals 15 miles an hour? Well, all you need to do is plug the 15 in here, and you find out that t is 2.5 hours, right? And you can just see that 15 times 15 minus 5, so you're going to have 150 on the bottom. 30 times 15 minus 75, you're going to end up with a time of 2.5 hours. Okay, so that is number 28. It is important to know how to do these problems. Very, very important. It is just systematic. You've got to make your drawing. However bad the drawing is does not matter, because the point is that you get what's happening. So actually, I'll just make sure that this actually looks more like a beach. Right? You're riding your bike to the beach, and then you're riding back. You're using your governing equation. You always need to determine what that is. You always need to say what you're looking for. They said very clearly they're looking for time. You put in words what you're trying to say. Trip to the beach, trip from the beach, time to the beach, time from the beach. You plug in your equation. You then plug in your numbers, and you're able to answer the question. That is the end of 12.6. I'm going to go through 12.7, and then we should be done for you to take your test.